Most of us take dry land for granted. We walk, drive, and build on it every day. But what happens when engineers need to build something where dry land doesn't exist? Think about bridges spanning rivers, tunnels beneath lakes, or piers stretching into the ocean. Suddenly, building gets a lot tougher. Water isn't just wet, it's heavy, it moves, and it hides what's below. Building underwater is like working in another world. You can't just dig a hole, pour some concrete, and call it a day. Instead, engineers have to outsmart the water and do it safely. The stakes are high. If something goes wrong, water can flood the work site or wash away the foundation. Lives and millions of dollars are at risk. That's why underwater construction is one of the toughest jobs out there. It may look impossible at first glance, but thanks to clever engineering, humans have found ways to build where water rules. Water brings a whole list of problems when you try to build under it. First, there's pressure. The deeper you go, the heavier the water sits on top of you. This pressure can crush equipment or flood a work site in seconds. Then, there's the flow. Rivers and tidal areas are always moving. Fast-moving water can knock over barriers, erode soil, or carry away tools. In some places, the current is so strong that even standing up is tough. Next, you've got the ground below. Underwater soil is often soft, muddy, and unstable. It can shift without warning. Sometimes it's impossible to see what you're working on because the water is cloudy. Poor visibility makes precision hard. Finally, let's not forget temperature. Cold water can freeze equipment and put workers at risk. Altogether, these challenges make underwater construction a dangerous and complex job. Keeping water out of a construction site is an epic battle. Even a small leak can spell disaster. Water wants in. It seeps through cracks, presses against walls, and sneaks up from below. If you can't keep it out, you can't build. But why is it so important to keep water away from construction? Concrete won't set underwater unless you pour it a special way. Workers need to see and move freely. Tools and machinery can't work right if they're flooded. Safety is another concern. Nobody wants to risk their life in a leaky, collapsing pit. Engineers use several lines of defense to hold back the water. They build walls, pump out water, and monitor constantly for leaks. It's a game of patience and precision. If you can't keep the worksite dry, the whole project is in trouble. That's why so much effort goes into controlling water before anything else. Enter the cofferdam, a builder's best friend underwater. A cofferdam is a temporary, watertight enclosure. It's built by driving steel sheets, earth, or even concrete into the riverbed or seafloor to form a box or ring around the area you want dry. Once the walls are in place, powerful pumps remove the water inside. The result? A dry island in the middle of a river or lake. Now, construction can begin as if you were on solid ground. There are several types of cofferdams. Sheet pile cofferdams use interlocking steel panels. Earth cofferdams are made from packed soil or rock. Sometimes engineers combine both for extra strength. The type depends on water depth, soil, and project size. Building a cofferdam isn't easy. The walls must be strong enough to resist water pressure and keep out leaks. If they fail, the site can flood instantly. After the cofferdam is in place, engineers need to dig down to something solid. Rivers and lakes often have layers of soft mud, sand, or silt. None of these are strong enough to support a bridge or building. You have to get to bedrock or at least firm soil. Excavators and pumps remove the muck inside the cofferdam. Sometimes divers help guide the machines. As they dig, workers must watch for shifting soil. If the ground moves too much, it can weaken the cofferdam or cause the walls to cave in. The deeper the digging, the greater the risk. Water pressure and soil movement grow with depth. Engineers use supports and sensors to check for danger at every step. Once they reach bedrock or stable soil, it's time to lay the foundation. But first, there's one more challenge: the seal course. The seal course is a thick, watertight layer at the bottom of the cofferdam. Its job is to stop water from seeping up through the soil. Pouring a seal course underwater isn't easy. The water must stay out, and the concrete must set right. Enter the tremie method. A tremie is a long pipe with a hopper at the top. Workers lower the pipe to the bottom of the cofferdam. They pour concrete through it, starting below the water's surface. As the concrete flows out, it pushes water away and fills the space evenly. This process keeps the concrete from mixing with the water and washing away. The result is a solid, smooth seal that blocks leaks. Once the seal course hardens, pumps can remove the last traces of water. Now the work area is dry, stable, and ready for heavy construction. With the water gone and the seal course in place, construction looks almost like it does on land. Workers build forms, tie steel rebar, and pour concrete for foundations and columns. Cranes and trucks move in materials. The site buzzes with activity. Engineers check the seal and walls constantly. Any sign of water seeping in means repairs are needed fast. Pumps stay ready in case water sneaks through cracks. Building continues upward. Columns rise, beams go in, and concrete cures. At each step, quality control is key. Mistakes can mean big trouble later, especially if the structure has to stand up to waves, tides, or floods. When the foundation and supports are finished, the cofferdam can be removed. The structure now stands strong, ready to face the water on its own. Even with the best planning, water still tries to cause trouble. Pressure pushes on every wall and crack, and seepage finds its way through tiny gaps. If a pump fails or a wall shifts, the site can flood in just a few minutes. The soil around the cofferdam can move, especially after a heavy rain or when fast currents hit. This can buckle the walls or let water in. Poor visibility makes it tough to spot problems early on. Engineers use sensors, cameras, and regular inspections to stay ahead of trouble. They keep backup pumps and materials on hand for quick repairs just in case. The work is never easy, but, careful planning and constant vigilance keep workers safe and projects on track. Cofferdams aren't the only way to build underwater. For deeper water or, bigger projects, engineers use caissons, these huge hollow structures that get dropped into place and filled with concrete. Some caissons are open at the bottom so workers can actually dig inside, while others are closed and sunk to just the right depth. Then you've got pile foundations, which use long, strong columns driven deep into the soil or rock. These piles support bridges and buildings above water. Sometimes, engineers use precast elements, basically ready-made pieces built on land, then floated and set into place. Each method has its own challenges and advantages, and honestly, the choice depends on depth, soil, and what's being built. It takes brains and teamwork to control water. Engineers study maps, soil samples, and currents before making a move. They design structures to resist water pressure, erosion, and even earthquakes. Sometimes they build coffered walls in stages, using smaller enclosures first. Other times, they'll divert the river or build during dry seasons. Whatever the method, the goal is always the same: make the water behave, at least for a little while. This control lets workers build safely, accurately, and efficiently. It's a battle, but one that humans are winning with every new project. Look around, and you'll see the results of underwater engineering everywhere. The foundations of the San Francisco-Oakland Bay Bridge were built with massive caissons and cofferdams. The Channel Tunnel between England and France was dug through water-soaked ground deep below the sea. Ports, harbors, and oil platforms all depend on underwater construction. Even dams, like the famous Hoover Dam, used cofferdams to hold back rivers during building. Without these techniques, we wouldn't have many of the roads, tunnels, and ports we rely on today. Underwater construction may seem far away from daily life, but it shapes the world around us. Every bridge you cross, every port that brings goods, and every tunnel that speeds up travel owes its existence to these smart engineering tricks. As cities grow and the world changes, we'll need even more underwater projects. Engineers will keep inventing new ways to tame water and build what we need. It's tough work, but it's how we connect our world, one careful, courageous step at a time.